Thermodynamics. According to dictionary.com, thermodynamics is a science concerned with the relations between heat and mechanical energy or work. In simpler terms, it's temperature, heat, and thermal equilibrium. Temperature is the average kinetic energy for the molecules in the substance. Heat is the transfer of thermal energy between objects or systems. Thermal equilibrium is being at the same temperature. For example, if there is a hot cup of water at 100 degrees Celsius and you want to cool it down, you would add ice at 0 degrees Celsius. It would reach thermal equilibrium when it reaches 50 degrees because both the ice and the water would be at 50 degrees. To calculate the amount of heat, we need to perform an equation. Q equals m times c times delta T. Q is the amount of heat. M is the mass of the substance. C is the specific heat capacity, which is different depending on each substance. Delta T is the final temperature minus the initial temperature. Here's an example. The C of H2O is 4,186 kg over kilograms times K. We also have 4 laws in thermodynamics. The 0th law says that there are two systems are said to be in thermal equilibrium with each other if both are in equilibrium with the third. For example, if A equals C and B equals C, then that means that A equals B. The first law is the conservation of energy law, which we saw back in the roller coaster project. The second law says that heat never flows spontaneously from cold to hot. It also says that the entropy of the universe is always increasing. For example, if you have cold pizza on your plate, it's not magically going to get hot. You have to put it in the microwave that has waves of radiation for it to get hot. The third law states that no system can reach absolute zero. If it did, it would mean that the particles would have no movement, no volume, and no entropy. Speaking about energy, we're going to talk about something that gives us energy and something we hear a lot about. A calorie. A calorie is the amount of energy used to raise one molecule to 1 degree Celsius. 1 calorie is 4,186 joules. This is a graph that determines at what temperature and atmosphere a substance is a solid, liquid, or gas. It can even be two things at once. For example, ice and water can both exist at 0 degrees. There are also different phase changes. When a substance goes from a solid to a liquid, it's called melting. A liquid to a gas, vaporization, and a solid to a gas is sublimation. These three reactions absorb heat. When a substance goes from a liquid to a solid, it's freezing, gas to liquid is condensation, and gas to a solid is deposition. These three lose heat. Here we have a graph that represents the different phase changes of water. With every different change of phase, there is a different equation. In class, we performed an experiment to see which alcohol gave out the most energy. We used methanol, ethanol, propanol, and butanol. At the end, we concluded that propanol was the one that was most efficient, but it was the most expensive, and then the second most efficient with the least price was ethanol. Here we can see the different equations for methanol, ethanol, propanol, and butanol. We also have an equation to determine how much each alcohol would cost per liter. This is the equation. In thermodynamics, we have exothermic and endothermic reactions. Exothermic reactions releases heat and endothermic take in heat. To determine if something is endothermic or exothermic, you first need an equation of a reaction. Then, using the special table, you add all the values and multiply it by the constant. Everything on the left side has to be positive. When you add it all together, if the answer is positive, it's endothermic, and if it's negative, it's exothermic. Here's an example. Here we see an equation that's given to us, and then we substituted each value for each solution with a different number. Then we added everything together, and we got negative 28.29. The answer was negative, so that means it's an exothermic reaction. In exothermic reactions, we see that they release heat and the PE increased is less than the PE decreased. In endothermic, it takes in heat and the PE increased is greater than the PE decreased. In some equations, you may encounter delta H. This means enthalpy, which is the same thing as heat. Another word we can learn is entropy. This means chaos or disorder. As the state of matter goes through solid, liquid, and gas, entropy increases. You might be wondering, when will we ever use entropy? We will use entropy to determine how spontaneous our reaction will be. We have a table that looks like this, you will see on the next slide, that helps us determine that. In this slide, we see a table, and we see that in entropy, if the entropy is positive and delta H is positive, and the delta H is negative, then it will always be spontaneous. If both delta H and delta S, or entropy, are positive, or both are negative, it will sometimes be spontaneous. If delta H is positive and delta S is negative, it will never be spontaneous. Delta S means entropy. Another way to determine if a reaction is spontaneous is using this equation. Delta G equals delta H minus T times delta S. If G is negative, the reaction is spontaneous. If it's positive, it's not. Thank you.